Hey Ramblers, today we're going to learn about proving that quadrilaterals are special quadrilaterals. That is, proving that they are more than just parallelograms, but that they could also be rectangles, rhombuses, squares, kites, trapezoids, or even isosceles trapezoids. So you want to pause this video often. You want to take notes and really get a sense of, think of this as kind of a flow chart type of a proof that you were going to start off, and then we'll have to make decisions as we see what we can prove. Okay, thanks for watching, and I hope this helps. Okay, so in this video, we're going to return to this flow chart that I showed you at the beginning of the second semester, because we're going to learn to prove that quadrilaterals are special quadrilaterals, like parallelograms, kites, and trapezoids. We're going to go further into parallelograms to show you how to prove that these quadrilaterals not only are parallelograms, but we'll see if we can prove that they are rectangles or rhombuses or squares. Before the video is over, I will also show you how to prove a figure is a kite, or how to prove a figure is a trapezoid, or even an isosceles trapezoid. So it's very important you pause the video or take a screenshot here, get this flowchart into your notes, because this is really going to be the foundation of our entire lesson and how we think about proving special quadrilaterals. So please take a minute and do that. Okay, let's get right into it and go back to how we prove quadrilaterals or parallelograms. Okay, so you should have known this was this for the last quiz of how to prove that a quadrilateral is a parallelogram. But as we start out, each time that we're proving special quads, we're essentially have to start with the fact that we know it's a quadrilateral. We can see in the diagram that there are four sides. So to take the first branch and to prove it's a parallelogram, we've already talked about how there are 5 different ways to do that. You can show that the opposite sides are parallel, like in the first diagram here, or show that I'm doing this at school. You can show that opposite sides are congruent, or you can show that the same pair of opposite sides are both parallel and congruent. You can show that the diagonals bisect each other, or you can show that the opposite angles are congruent. Now, it's very important that that's the way we get from the first, from a quadrilateral to a parallelogram. If you can't use any of those 5 methods to prove that we have a parallelogram, then you could have a kite or it could be a trapezoid. But let's put those to the side for a minute. All right. What we're going to always do in these problems is first try to see if we can prove it's a parallelogram. So that's the first step, is that we are going to show in step 1, can you show that it's a parallelogram? Okay, so again, so let's write this first step down and maybe take a screenshot or make sure that this is in your notes. Step 1, try to prove that the given quadrilateral is a parallelogram. So once we've proven that our quadrilateral is a parallelogram, we want to try and take the next step. Maybe we can, maybe we can't. If we can't, it stays a parallelogram. But we were going to try and prove that it's either a rectangle or a rhombus. All right, how do we do that? So we know it's a rectangle if we can prove one of 2 things, not both. So if you can prove that not only is it a parallelogram, but you can show that there's one right angle, or prove that it's a parallelogram and somehow you can show the diagonals are congruent. If you can do either one of those, you've proven not only is it a parallelogram, but it's also a rectangle. Now, if you can't prove it's a rectangle, it might just be a parallelogram, or maybe you can prove it's a rhombus. And you prove a rhombus also by one of 2 different methods. Actually, it's one of 3 different methods. So a parallelogram is a rhombus if you can show that that's a parallelogram with one pair of consecutive sides congruent, or it's a parallelogram with perpendicular diagonals, or it's a parallelogram and one diagonal bisects the opposite angles that the diagonal is connecting. All right, take a screenshot here, pause here, make sure you understand how to prove that a parallelogram is a rectangle or how it is a rhombus. Pause the video at this point, make sure that proving either of those two figures is in your notes. And then now we're going to move on to a square. All right, so once you've shown a parallelogram, and then you can prove that it's a rectangle or a rhombus, you can try to prove that it's a square by proving both. So a parallelogram is a square if it is both a rectangle and a rhombus. So if you can show that it's a rectangle by either of the two methods or a rhombus by either of the three methods, if you can show both of those are going on, then you have a square. Okay, let's take a minute for an example of how this works. Okay, let's take a look at this quadrilateral here. It's clearly a quadrilateral. So we've moved from a quadrilateral at the top, and now we need to see, can we prove it's a parallelogram? That's always step one. So clearly, by one of the 5 methods, we know that both pairs of opposite sides are parallel, so it has to be a parallelogram. So we move on to step 2. Can we then move from the fact that it's a parallelogram to something like a rectangle or a rhombus? So looking at the diagram, we see that we have one right angle, and that was one of the methods of proving a rectangle. So we know that this must be a rectangle. Not only is it a parallelogram, but it's a parallelogram with one right angle, so it's a rectangle, and you're done. Now, we could try to see, can we go a little bit further? Can we get down to a square from a rectangle? Well, in order to get it to a square, we would have to prove that it's also a rhombus. And you'll recall, with a rhombus, we'd need to show congruent sides, which we don't know. We just know they're parallel. We'd need to know that the diagonals are perpendicular, which we don't have any diagonals drawn in this figure at all. Or we have to show that a diagonal bisects the opposite angles. And once again, there is nothing in this figure about diagonals. So we can't go any further than rectangle. So that's the answer for this one. It's a rectangle. In this next example, we see that we have the diagonals drawn, and we have some information about the opposite angles. So clearly it's a quadrilateral because it has 4 sides. Now as we move down to a parallelogram, we can prove it's a parallelogram by this method here, because the diagonals bisect each other, just as the diagonals in this figure do. So it's definitely a parallelogram. Now, can we go any further? Can we show that this parallelogram is either a rectangle or a rhombus? Well, we recall that a figure can be shown to be a rhombus if a diagonal bisects the opposite angles. And not only can we show that the diagonal is bisecting them because the tick marks are all the same, but obviously those opposite angles are congruent. So this is definitely a rhombus as well. But it's important you recognize that we had to go through the same step every time. We have to first confirm it's a quadrilateral because of 4 sides, then show it's a parallelogram before moving further down. Okay, let's take a look at another example. Okay, in this example, we can see that once again we have a quadrilateral, and we can show it's a parallelogram by the method that the diagonals bisect each other. Now, but can we go any further? I mean, what else can we tell? Well, we know that it must also be a rectangle. It's a rectangle because not only do the diagonals bisect each other, but all the parts are congruent. So that means that the diagonals are congruent. So this figure is also a rectangle. But we can see from the figure that the diagonals also are perpendicular, which means that this figure is also a rhombus. So if a figure is a rectangle and a rhombus, this figure is also a square. All right, and those are 3 examples of how we can take a quadrilateral and prove not only is it a parallelogram, but it's more than a parallelogram. Let's take a look at some of the other quadrilaterals that we'll be dealing with. Okay, so if a quadrilateral can't be proven to be a parallelogram, it's possible that we can prove it's a kite, or it's prove that it's a trapezoid and maybe beyond. Let's take them one at a time. Let's see what we can do to prove if something is a kite.
So in order to prove a kite, we need to show that no sides are parallel and two pairs of consecutive sides are congruent. So let's pause there, make sure you get that in your notes. So if a quadrilateral is not a parallelogram, maybe it's just a quadrilateral, or perhaps it's a kite if you can show that no sides are parallel and that two pairs of consecutive sides are congruent. To show a quadrilateral is a trapezoid, we have to show that there is only one pair of opposite sides parallel, or exactly one pair of opposite sides parallel. But we can go a little further and show that perhaps the quad is an isosceles trapezoid. To do so, we would prove that the trapezoid is, that the quadrilateral is a trapezoid, but then show that the non-parallel sides are congruent. Okay, so please take a screenshot here, or make sure you've reviewed in your notes that if we're trying to prove a trapezoid, we have to show that there is only one pair of opposite sides parallel and that the non-parallel sides are congruent. Will make it an isosceles trapezoid. Okay, let's take a look at a couple of examples and give you some practice with recognizing those. Okay, let's take a look at this the first problem here on the left. And we can clearly see that it's a quadrilateral, so we know that much. But then we can see that the opposite sides, while we know these are parallel, these two are not congruent, indicated by the different tick marks. So this is not a parallelogram. We can't go down that branch of our tree here. However, we do see that we have one pair of opposite sides parallel, as indicated by the tick marks. So this is not a kite, because we have opposite sides parallel. However, since we only have one pair of sides parallel, it's a trapezoid. So we've been able to prove that. And by the fact that the opposite, the non-parallel sides are congruent, means that this is an isosceles trapezoid. Okay, so looking at this second example, the one on the right, we need to go through the same thought process. First of all, it's obviously a quadrilateral, but we can't prove that it's a parallelogram because clearly the diagonals, one of the diagonals is not bisected, which it has to be in a parallelogram. However, maybe it would be best if we put some, label some of these vertices. So you can see from the diagram that BD is the perpendicular bisector of AC, which means B is equidistant from A and C. Also, it means that D is equidistant from A and C. So this figure is clearly a kite because it's not we do not have any sides parallel, and we have two pairs of consecutive sides congruent. All right, Ramblers, this is kind of a long video, a lot of material here, but I hope you took a lot of screenshots, it's important that you organize this information in your head, and ultimately it has to be memorized. You have to be able to go through this flow chart of thinking, proving it's a quadrilateral first, then a parallelogram. If you can't do a parallelogram, try and prove that something's a kite or a trapezoid. We'll have some examples for you doing the homework, but thanks for watching.